Hi everybody, this is Mr. Folly. Oops, and my pen's not working. This is Mr. Folly, and welcome to part 2 of Big Ideas. Ooh, we're on 7, aren't we? Ooh, Big Idea 7. A little equilibrium fun. So we're going to talk about the magnitude of K and its impact. Remember, K is Kc, equilibrium concentration, Keq, equilibrium concentration, Ka, acid concentration, Kb, all those things the same, okay? So K is products raised to coefficients over reactants raised to coefficients. A large K means products are favored. That means lots on top. A small k means reactants are favored. That means lots on bottom. What do I mean by top and bottom? Top, ooh, that didn't work. Top, ooh, that didn't work. Top, well, let's try it. Change the color. Might as well if we're doing this. Bottom, okay? Bottom. All right. So if k is much less than 1, and it's shown, and they do show with this many less than signs, the reaction barely happens at all. Oh, I'm going to sneeze. I dodged my sneeze. Okay. Dissolving an insoluble salt is an example where K would be much less than 1. It dissolves, but just barely. If K is much more than 1, should be capital K, I apologize. K equals 1,000 or more, and really 100 or more. I'm going to back that off a bit. 100 or more, the reaction goes to completion. Examples. So if A is in equilibrium with B, and K is 2.55 E6, this is a big K. This would be completion. Barely equilibrium. This one has a small k. So that means far left, very, few products. Okay, so now we're going to talk about manipulating K. So we can change K. Remember how K is products over reactants raised to their coefficients, right? And here it is balanced. We had some of these H craziness for balancing, where it's like, well, it's got to be 1A, or it's got to be exactly 1D. So right now, the way it's written, I have products, D cubed, and A squared B. But what if I doubled the coefficient? Isn't that a true statement? That if I doubled it, I would have D to the 6th, B squared, A to the 4th, right? And if that happens, that means K, what did I do? Is squared. If the reaction is reverse, we're going to invert it. Oh, I didn't write this down. This would be K to the negative 1, right? So if I flip the reaction around, my products used to be my reactants, and my reactants used to be my products, so all I did was invert it. So that's K to the negative 1, okay? So if my K value was 20, and I reverse the reaction, my K would be 1 over 20. There we go. If you have 2 steps, each step has a different K. The way you find K total is by multiplying it. So, looks like I've got some pretty bad typing stuff in here. So let's take a look. This shouldn't be exponent intended. So K total is 2.5, E negative 3 times 1.0 E negative 2, which is going to be 2.5 E negative 5. All right. Calculating equilibrium expressions. These are ice diagrams. Yeah, if you remember what an ice diagram is, you remember sunshine. So let's do it. You can look at equilibrium reactions in steps. You may have seen it called a Rice diagram. I call it an ice diagram. Or a BCA reaction. So I stands for the initial concentrations, C stands for the change in concentrations, and E stands for equilibrium concentrations or ending concentration. Suppose that at a temperature of 400 degrees Celsius, a mixture of 3 moles of H2, moles, it needs to be molar, and 1 mole, needs to be molar, of N2 is placed in a 4-liter container and allowed to reach equilibrium. So I see this 4-liter container and I keel you 3 moles. I'm changing it right away to molarity, 0.75 molar. 3 divided by 4 is 0.75. I don't think that's math. It's stumping anybody. 1 divided by 4 is 0.25 molar. Okay. Find the equilibrium concentration of each. So we're in moles, not molarity. The temperature is given because temperature can change K, so really the temperature we don't really care about. So I have this reaction, N2 plus 3H2 yields 2NH3, and I have my molarities that I put in there. Initially, these are my molarities. Now, this is kind of freaky because it seems kind of elementary and little baby Chucky-ish and not helpful, but it's outrageously helpful. So what we have is 0.25 minus X. Why 1X? Because my coefficient is 1. Hydrogen will lose 3 times as much because it has a coefficient of 3. And this is a product, so it's going to gain instead of lose, and it's going to lose 2 instead of 1 because of the coefficients. And then in the end, I have this monstrosity. Okay? So now I have K equals this. I have a K. I plug in all of this stuff, and I go, ooh, what a math pain. So let me get out my calculator. I hope you have a TI 84. If you don't, and you have a TI, whatever the CE one, it's slightly different, but it's a little bit easier. If you don't have an 84 or the CE or whatever from TI, there is a way to do this. You can look up solver on the internet. It'll show you. So what I'm going to do first, I'm going to hit the word that says math. I'm looking for the word math. It's 2 buttons underneath second. And then I'm going to press up twice. Oh, up once. So, and where it says B solver, I'm going to hit enter. And my screen says equal 0 equals. So we solve above for 0. Okay, so do you see how this is not 0? So to solve it for 0, we just and subtract 1.64 e negative 4 from the side. That's what I did. Okay. So now that it's solved for 0, I'm going to type that in my calculator. Parentheses, 2x. Now, I didn't, mine says theta. Why does it say theta? Parentheses, 2x. I'm going to stick with theta because I don't know how to change it. 2 theta quantity squared, divided by parentheses, 0.25 minus x. See how the parentheses are annoying? Yours probably says x. I'm mad mine says theta. I'm going to take the batteries out here in a minute. And then also notice how I have to double parenthesize these because they both go on the bottom. And I type all that in, close my parentheses, minus 1.64, e negative 4, enter. It says x equals. You type in 0.00 basically every time. For e's of e negative 2 or smaller, this is your guess. So what happens is this computer thing, when it says x equals, if you remember, you get a different number of roots based on the number of x powers you have there, whether it's 2 or 3 or whatever it is. And once you have that, you have to give me, they say, well, which x do you want it closest to? And we always want the one closest to 0. So we'll do 0.001, okay? Sometimes I go 0.0001, and I put in 2 or 3 or zeros or whatever it is, and then you hit alpha enter. You got to hit alpha. The alpha button is green, and enter, and that enter button is gray. It changes x to 0.002045. Okay, dot. You have to scroll all the way to the right to get your e value. Okay, this one doesn't have an e value; it's just 0.02045. Okay, now what you do? So that is x. Now plug that into this equation. Okay, at the equilibrium line, right? So if I have 0.75 minus 0.02045, 0.25 minus 3 times that, and then this one is going to be 2 times 0.02045. It is not uncommon for some of these to not matter. So see how I'm subtracting that number off? It barely matters, right? I get 0.074. NH3 would be a small number, but it compared to 0 is a much bigger change, a much more significant change, right? So my K value is very small. What was it? E negative 4. So my K value is very small, okay? N2 is this, H2 is this, and H3 is that, okay? That's it. Hey, under 10 minutes for ice diagram. By the way, that solver works for anything you got to do in math. It was photomath before there was photomath. Toodles.